Hello lovely people, what is up? Today we are solving LeetCode problem number 693, binary number with alternating bits. So in this question we are given a positive integer n and we are asked to return if it is true if its binary representation contains alternating bits with no two adjacent bits are the same. Otherwise we return false. For example, 101010 is alternating and it is true. Also, 101 is alternating, so it is true. 111 or 100 are not alternating, so we return false. So what is the key idea here? Here we inspect the number bit by bit starting from the least significant bit to the most significant bit. Least significant bit being the rightmost bit and the most significant being the leftmost bit. At each step, we extract the last bit and we compare it to the previous bit, and if they are equal, we return false, and if they are not equal, which is otherwise, we continue. So why do we start from the right? Computers naturally work with bits from right to left. So for example, if n is equal to 5, the binary representation of it is 101 and we start here at the rightmost bit, because when we divide n by 2, it gives us the last bit, and if it is greater than 1, it removes the last bit. This makes checking very easy and fast. So again, coming back to our example 5, which is 101, we keep a variable, let's call it previous, which will be equal to 1, which is a dummy value. And then in the first iteration, we divide 5 by 2 to get the last bit, which is 1. We compare it with previous minus 1, which is different, so we don't return false. So, and then we update the variable previous to 1, and then it becomes n is greater than 1, which is 2, and then in the second iteration n becomes 2 and the last bit is 2 divided by 2, which is 0, and we compare it with the previous bit, which is 1. It is different, so we don't return false. And then we update value of n as 1, and then when n is equal to 1, which is 1 divided by 2 is equal to 1, and we compare it with the previous bit, which is different, and then we update the value of n to 0. Since the value of n becomes 0, the loop ends here, so no equal adjacent bits found, and we return true. So hope you guys understood the logic behind solving this problem. Now let us take a look at the code. Here we initialize a variable previous to -1, and then we start a while loop where n is strictly greater than 0, and we initialize a variable current equal to n divided by 2, n mod of 2. This returns the remainder when it divides by 2. And then we check if current is equal to previous, so we write if current is equal to previous, we return false. And then if previous, and then we initialize previous is equal to current, and then we initialize and then n is equal to, we are moving the bit by 1. So essentially what we are doing it is we are removing or not considering the last bit. That is what we are using two greater than symbols. And then when while loop exits, we return true. So now let us try running the code. As you can see, the code is running in the most optimal time. The time complexity is O of n. The time complexity is O of k, which is the number of bits in n. So it will be O of log n, and the space complexity is constant space O of 1. So that's all for today. Hope you guys enjoyed today's video. See you in the next one. Bye bye.